Simultaneous equations. Today we are going to talk about these equations. Let me start with an example. There are two equations here with the symbols x and y. So there are two unknowns in these two equations. Now, previously I have talked about equations with just one symbol, like x, and I've talked about how to solve these equations. Now, this time we have equations with two unknowns, x and y. It is actually not possible to find the x and y if we have only one such equation. We need two equations together. Then there would be enough information to find the answers for x and y. Now, what do we mean by the answers or the solutions x and y? It means a set of numbers, a number for x and maybe a different number of y, that when you substitute into these equations will satisfy them. And then what do we mean by satisfy them? That means that if we say look at the first equation, right, when we must find numbers for x, a number for x and a number of y for y, that when we put these numbers into the equations, the left hand side will be equal to the right hand side, and this must be true for both the equations. And these two equations together are called simultaneous equation. That means that we must find numbers for x and y that will satisfy the two equations at the same time, satisfy them simultaneously. Now that might seem a bit abstract, so let's do it. Let's try and find the answers, values for x and y that can answer this question. Now I shall start with one way of doing it. Let me call this equation number 1 and equation number 2. Now this is part of the way of finding the answer, to label the equation, to number the equations. This is because we are going to create quite a few equations that we must work with, and we need to give them numbers to keep track of them. So let us start. The first step is to look at one of the symbols. Let's look at x. Now in the equation 1, that's equation 1, the x has a coefficient of 1. Now if you remember what coefficient means, it means the number in front of x. So if there is no number, it just means 1 times x. In equation 2, the coefficient of x is 2. So that's the number that multiplies x. The way is to do something to the equations to make the coefficients of x the same. Meaning, for example, in equation 2, the coefficient of x is 2. In equation 1, coefficient of x is 1. So 1 and 2 are different. Right? The numbers in front of x are different. We want to make them the same. So for example, instead of the 1x here, we want to turn it into 2x so that it becomes the same as the x in equation 2. Now how do we turn the number there into 2x? Well, the way is simply to multiply it by x. Now remember that in an equation, if we multiply one side by 2, we must also multiply the other side by 2, so that left and right are still equal. Then we can call that an equation. So let's do that. Let's multiply 1 by 2. Now there are different ways to write this. You can write it out in words. I multiply equation 1 by 2. Now I like to write it in a rather simple way. I'll just write 2 times bracket 1. So this is my way of writing it. The bracket 1 means equation 1, and the 2 times there means that I want to multiply both sides of equation 1 by 2. So let's start. We need to multiply the left side of equation 1 by 2. Now we have to be careful when we do that. It is easy to think that we just need to multiply the x by 2 and not the 2y. Now that's wrong. We have to think about the left side as a whole. Meaning that if you actually know x and y, and you're going to calculate the left side, you must actually calculate x plus 2y first before you multiply by 2. Now, to make this quite clear, let me just start by putting a bracket around the left side. A bracket always means that we must do the sum in the bracket first. And then I multiply both sides by 2. Now it will be correct. And it's quite clear that we have to do the x plus 2y first. So you can see that if I just multiply 2 by x and leave out the 2y, it's different and it's wrong. Let's simplify that. Let's remove the bracket for that. We need to multiply 2 by each term in the bracket. That gives 2x plus 2 times 2y, which is 4y. And on the right side, I have 1 times 2, which is 2. So now, I have a 2 in front of the x, and the number in front of the x is now the same as in equation 2. I need to give this a name to keep track and to refer to it afterwards. So I have just turned equation number 1 into equation number 3 by multiplying both sides of the equation 1 by 2. Next step. Now the next step is called elimination. What that means is that I should take equation 2 and equation 3 and subtract them. Let me write that down. Now I shall write that now as bracket 2 minus bracket 3. Now, and what I mean by that, this is my own notation, if you remember. What I mean by that is that I want to take equation 2 minus equation 3. Now that is a little bit abstract, so what I really mean is that I want to take the left side of equation 2, this one, minus the left side of equation 3, and I want to take the right side of equation 2 minus the right side of equation 3. So let's do that and see what happens. Now, the left side of equation 2 is 2x plus y. The left side of equation 3 is 2x plus 4y. So let's do the left side. And when we subtract, we can look for like terms to simplify. So the like terms will be the term in x for a start. So 2x minus 2x is 0. Right? I'll write that down. The 0 there comes from 2x minus 2x. Now the next one is y minus 4y. So y minus 4y, y is the same as 1y. So that's 1y minus 4y. So we do 1 minus 4 is minus 3. Minus 3y. Alright, so we have just subtracted the left hand side. Let's go over to the right hand side. 3 minus 2 is 1. Now, we have a much simpler equation now. Notice that the x is gone and only y remains. And we can now solve for the y quite easily. So let me write that down, write that out here again without the 0. Minus 3y is equal to 1. So we can find y now. On the left side we have minus 3 times y. On the right side we have 1. So we like to find y. We need to get rid of the minus 3. We can do that if we divide both sides by minus 3. So let's do that. Y is equal to 1 divided by minus 3. And that's the answer for y. Y is equal to minus 1/3. We have one answer now. We have just found y. The next thing is to find x. The way to find x is to take this answer for y. Then y is minus 1/3. Go back to the first two equations. Pick one. So I'll just pick equation 1. Substitute the value for y, the number for y, into equation 1 and then solve for x. Let's do that. Alright, now substitute in 1. So we go to 1, we have x plus 2y, x plus 2 2y is 2 times y, and y is minus 1/3. So I'll replace the y by minus 1/3. Okay. Now I need to put a bracket there, otherwise it looks just like 2 minus 1/3. But really it is 2 times 1/3 because it's 2y, it's 2 times y. So 2 times the bracket minus 1/3 equals to 1 on the right side. So there, now we have an equation for x that we can solve. Let me simplify that. 2 times minus 1/3 is minus 1 minus 2/3. Okay, so x will be, to get rid of the minus 2/3, I add 2/3 to both sides of the equation. So x is 1 plus 2/3, which is equal to 5/3. So now we have two answers. We have both answers. Y is minus 1/3 and x is 5/3. So as with the equations, we should double check that our answer is correct. So we should substitute these two answers back into the original equations and check that the left hand side is equal to the right hand side. So let's do it for equation 2. Left hand side. In equation 2, the left hand side is 2x plus y. So let's substitute that. 2x is 2 times x, and x is 5/3. So let's do 2 times 5/3. That's the 2 times x plus y, and y is minus 1/3. So let me change the plus to minus 1/3. Let's work that out. So, right, if you work this out, 2 times 5 is 10. So 10/3 minus 1/3 will be 9/3, which is 3. Which is the same as the right hand side. Therefore, x and y satisfies equation 2, meaning that if you substitute x and y into equation 2, the left hand side is equal to the right hand side, and therefore the equation 2 is correct. And to be very sure, you should do it for equation 1 as well, and when you check that that is also satisfied, you can be sure that y, the numbers for y and x that you got are the correct answers. Let us now look at a slightly more difficult example. simultaneous equations with fractions. Now, fractions are always more complicated to work with than just numbers because they have denominators. So, the way to do this question is to get rid of those denominators. How can we do that? Well, for a start, let's call that equation 1 and equation 2. Look at equation 1. The denominators are 2 and 3. Now if it is just x over 2 on the left side, I can get rid of the denominator if I multiply by 2. Then 2 will cancel with the 2 at the bottom. But I also have y over 3. Now if I just have y over 3, I can get rid of the 3 if I multiply this by 3. Right? But since I have both 2 and 3, I can get rid of both of the denominators if I multiply by 2 times 3. That means 6. If I multiply the left side by 6, I can get rid of both of these. Let's try that. So this means that I want to multiply 6 by equation 1, meaning by both the left side and the right side of equation 1. So remember, for the left side we have this plus this, we have 2 terms added together, and when we multiply by 6, we have to multiply by each of the terms. Okay, because these 2 terms are supposed to be added together first before we multiply by the 6. And remember, added together first means the same as having a bracket around them. And when you want to multiply by them, it's the same as having to remove this bracket. Now let me write that out explicitly again, just to be very clear. So on the left side, instead of just 6 times x over 2, I really need to add x over 2 to y over 3 first before I multiply by 6. On the right side, I have just 1 times 6. So then, to do the left side correctly, I should then remove the brackets, and that means I multiply 6 by each term in the bracket. So 6 times x over 2, I do 6 divided by 2 to get 3x. 6 times y over 3, so 6 divided by 3 gives 2, 1. Right side, 1 times 6 is 6. So we get our new equation. Now, with more practice, you will begin to remember that if you have 2 terms or more added together on one side of the equation, if you multiply by a number like 6, you must think of this as a bracket, and which means that you must multiply the 6 by each term on the left side, and not just one of the terms. Let me call that equation 3. So, moving on to equation 2. Now in equation 2, on the left side, the fractions have 3 and 4 at the bottom. I want to get rid of both of them. So the simple way is to multiply the left side by 3 times 4, which is 12. So let me write that down. 12 times the equation 2. So remembering now that to multiply 12 by the left side, I really need to multiply 12 by each term on the left side, not just x over 3. We can now do the multiplication one by one. So 12 times x over 3, if we do 12 times x over 3, now the 12 would be divided by the 3, that gives 4. Next, we multiply 12 by y over 4. So the 12 would be divided by the 4 to give 3. We have 3y. There's a minus sign there, so that carries over. And on the right side, we must also multiply by 12. So 12 times 2 is 24. I'll call that equation 4. So we have 2 equations now with no more fractions. So we have made it simpler to work with. Then in the next step, we need to apply the same ideas from the last example, which is that we look at these 2 new equations, we look at one of the terms, one of the symbols. Let's say x. We look at the numbers in front of x. These are 3 and 4, and we want to make them the same. So one simple way to make them the same is to multiply the numbers, multiply each equation by the number in the next equation in front of the x. Meaning, multiply this equation by 4 and multiply this equation by 3. Now let's try it and see why it works. So let's do 4 times 3. Now 4 times this, remember, multiply each term by 4, not just the 3x by 4. So 4 times 3x is 12x. 4 times 2y is 8y. And on the right side, 4 times 6 is 24. Let me call that equation 5. Next, multiply this equation 4 by 3, the number in front of x in the other equation. So 3 times 4x, let me write this down first, 3 times the equation 4. So we need to multiply 3 by each term on the left side. So 3 times 4x is 12x. 3 times 3y is 9y. And there's a minus sign here that carries over. And on the right side we have 3 times 24. 3 times 24 72. Call that equation 6. What you see now in the two new equations is that the number in front of x has become the same in the two equations. Notice the 12x there and the 12x there. And that happened because we multiply the 3 in this equation by the 4 in the other equation, and we multiply this equation here with the 4x by the number 3 from the other equation. Okay, that's how we end up with both 12 and 12x in the new equations. Now, and this is what we want. We want the same number in front of one of the symbols, because then we can subtract the two equations. Then when we subtract these two equations, the x will be cancelled off. Let's do that now. Let's take equation 5 minus equation 6. So in my own notation, I'm just going to write bracket 5 minus bracket 6, which means that I take the left hand side of equation 5 minus the left hand side of equation 6. Let's do that. So 12x minus 12x is 0. 8y minus 9y. Right, be careful. It's 8y minus 9y, and not just 8y minus 9y. So minus is a plus. Therefore, it's really 8y plus 9y, which is 17y. And on the right side, we must subtract as well. So 24 minus 72. That would be 48. And now we have just gotten rid of x so that only y remains. Now we can find y more easily. That's just 0, so ignore that. That's 17 times y, and we can get rid of the 17 if we divide both sides by 17. This gives y is equal to 48 over 17. Now unfortunately we cannot simplify this fraction any further. So let's move on to find x. We can find x by substituting into one of the equations. Now I would choose equation 3 rather than equation 1 because there are fractions there and it might be more complicated to work with. So let's try equation 3. Let's substitute into equation 3. That gives 3x. X is what we want to find. So 3x plus 2y. 3x plus 2y being 48 over 17 is equal to 6. So we have just substituted the value for y like this. So now we have just x in this equation, and therefore we can go on to calculate x. Let me just work through this for a few steps. So 2 times 48 is 96 over 17 is equal to 6. And we subtract from both sides. 3x equals 6. We subtract this fraction from both sides, that gives 6 minus that fraction here. And then we need to calculate 6 minus 96 over 17, a little complicated. And we have 3x on the other side, so we need to divide both sides by 3 in order to find x. So I'll just say dot 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 and leave that as an exercise. Let's now look at some problems that can give simultaneous equations. Okay, now suppose we have two numbers. Let me write that down. You have now the sum of these two numbers is 20. The difference between the numbers is 2. So the question is, what are the two numbers? So a rather difficult question, perhaps. It is not very obvious might not be obvious how to do this. We can of course try guessing at some answers, but let's try and do it using algebra. Now, as you know, in algebra, if there is a number that we don't know, we let it be x or some other symbols. So now that we have two numbers here, I shall let the two numbers be x and y. So let them be x and y. Okay. Next, we want to use the information given to make some equations used with x and y. So x and y are the two numbers, and the sum of these numbers is 20. That means the sum of x and y is 20. We can write that down. The sum of x and y means x plus y. It is 20 means that this is equal to 20. There we have one equation. Next, the difference is equal to 2. So the difference of x and y is x minus y, and this is equal to 2. There we have our next equation. Now you might wonder why the difference cannot be y minus x instead. It can. If you choose y minus x, then when you get your final answer, the numbers for x and y will just be exchanged. If you don't understand what that means, let me work through this first, and then you can try it out and you'll see. So we have these two equations with x and y, with two unknown symbols, and we want to find x and y. So this is the kind of problem that we have just seen for simultaneous equation. So if you remember, in order to find the answers, we must look at the numbers in front of each symbol, let's say of x, and try to make them same. And then we subtract them, and then we can work out the answer. So in this case, the numbers in front of x and y, in front of the x, are both 1. X without a number just means 1x. So we have 1x and 1x in both equations. So they are already the same. And in fact, the number in front of the y are also the same, except that one has a minus sign. Let me call this equation 1 and equation 2. So since the numbers are already the same, things are more convenient here, things are easier. I can just look at, say, the y, alright, I can just notice that we have a plus y in one equation and a minus y in one equation, so that if I just add them, the plus y and the minus y will cancel. So this is something that we can notice if we look at it. So therefore let's just try and add them and see what happens. Let's do equation 1 plus equation 2. So on the left side we have x plus x, which is 2x. We have y plus minus y, which is 0. And on the right side we have 20 plus 2, which is 22. And we now have a simpler equation, 2x equals 22. Therefore, we can find x, just divide both sides by 2. And we have 22 over 2 equals 11. So now we have found the answer for x. Next, we need to substitute this number into one of the original equations to find y. So let's try substituting it into 1. Okay. Now you can write it out in English. Substitute x into 1. Now I just use my own way of writing it. I like to draw an arrow pointing to 1, which means putting this number for x into 1. So x is equal to 11. Put that into 1. Put that into equation 1. So the x here becomes 11, and we have 11 plus y on the left side equals to 20 on the right side. Therefore, we can now find y. Subtract 11 from both sides to get rid of the 11, on the left side, and we have y equals to 20 minus 11, which is 9. So we now have our answers that x equals to 11 and y equals to 9. So just to be very sure, let's substitute it into the second equation. Equation 2, left hand side. The left hand side is x minus y, which is 11 minus 9. And this is equal to 2, which is equal to the right hand side. So therefore, equation 2 is satisfied, meaning that x equals to 11 and y equals to 9 are the solutions to equation 2. So likewise, we can check that for equation 1 as well. And then we confirm that these are indeed the answers. Right, let's look at another example. Okay, there is a man who is the boss of a company. He has 7 people working for him. So these are the 7 workers. Right, so we have a boss, and we have 7 workers. So together they earn, in 1 week, they earn $520. Now, if instead you have 2 bosses and 17 workers, then they earn in 1 week $1,220. So the question is, how much does each boss earn? So once again, we can use algebra to solve the problem. So the unknown here are the earnings of the boss and of the workers. So let the earning of the boss be X and the earnings of each worker be Y. So in the first week, when you have one boss and 7 workers, they earn $520. So if we, in terms of X and Y, it means that X is the amount that the boss earns. Now one worker earns Y dollars, so 7 workers earn 7 Y dollars, and the total here is 520. Likewise, when we have 2 bosses and 17 workers, 2 bosses earn 2x, 17 workers earn 17y, and the total is $1220. So now we have our simultaneous equation, and we can try and find the answer. So call that equation 1 and equation 2, and start by looking at, say, the number in front of the x. Doesn't have to be x, of course. You can also look at the numbers in front of the y, whichever is easier, and easier usually means smaller numbers. So in this case, we have 1 in front of the x in equation 1 and 2 for equation 2. So we can make them same if I multiply the equation 1 by 2. Alright, then the x here would get a factor of 2 and become the same as in equation 2. So let's do that. 2 times equation 1. So I'll get 2x two times 7y. Remember, we must multiply each term on one side by 2, because the whole of the left hand side, we must think of it like in a bracket, because we are supposed to do the addition first before we multiply. So we multiply each term by 2. So 2 times y is 17, is 14y. And on the right hand side, we have 2 times 520, which is 1040. Call that 3. So now we have the number in front of the x, same as for equation 2. Let's now subtract them. Now I'll take equation 2 minus equation 3. So remember, it's my own private notation that bracket 2 minus bracket 3 means equation 2 minus equation 3. And that in turn means that I must take the left hand side of equation 2 minus the left hand side of equation 3 first. So on the left hand side we have 2x minus 2x, that's 0. We have 17y minus 14y, that's 3y. And we have 1220 minus 1040. Right, and that would be $180. So the equation is now simpler. We have just 3y is equal to 180. Therefore, you can find y if we divide both sides by 3. Right, divide the left side by 3, gets rid of the 3 here. Divide the right side by 3, gives 180 over 3, which is 60. So y is the earning of each worker in 1 week, and that's $60. We want to find the earning of the boss in 1 week. So let's use, say, equation 1. Let's substitute y into equation 1. So again, using my own notation, I just draw an arrow to put 60 into y equals to 60 into the equation 1. So I have x plus 7 times 60. X plus 7 times 60 right is equal to 520. So now I have an equation with just x, no y. I can try and find x now. So 6 times 7 is 42. I can now subtract 420 from both sides. On the left side, only x remains. On the right side, 520 minus 420. That's equal to 100. There. So we have now found the earning for each boss in a week to be $100, for each worker $60. And to be very sure, we should substitute these numbers back into the original equations, each of the equation, to check that the left hand side is equal to the right hand side. And once we have done that, we can be sure that we have got the right answer.